So we're always hearing about how AI can learn, right? But how does it actually know stuff? Today, we're going to pull back the curtain and look at the logical engine, the real backbone that lets an AI reason and make decisions, to actually understand its world.
And yeah, look, a ton of AI today is all about learning from these giant piles of data. But you know what? That's really only half the picture. We're going to dive into a totally different kind of AI. This is one that doesn't just spot patterns, but one that genuinely understands and acts on what it knows, all by using formal, provable rules.
Okay, so the key concept we're talking about here is something called a knowledge-based agent. Now, instead of just crunching raw data, its intelligence comes from, well, think of it like a carefully curated library of facts and rules. It's like its own personal book of knowledge that it uses to figure out its way in the world.
And this really gets to a huge idea in AI called declarative knowledge. See, instead of giving the AI a step-by-step instruction manual on how to do something, we just tell it what's true. And at its heart, this agent works with just two simple commands. First, we tell it new facts, which it adds to its knowledge base, and then it can ask itself questions to decide what to do next. It's this constant loop, right? Learn something new, then ask, okay, based on what I know now, what's the logical move?
All right, so how do these agents actually store all this knowledge? Well, the most basic form of logic they use is something called propositional logic. This is really the ground floor, the absolute foundation. It deals with simple statements that can only be one of two things, either true or false. No in between.
The best way to think about it is like a bank of light switches. Every single statement, what they call an atomic proposition, like "it is raining," is either on or off, true or false. And then we use these logical connectors like and, or, and implies to wire them all together, creating rules that link up all these simple facts. And boom, that's the knowledge base the AI can actually use.
And this is where it gets really cool. The agent can actually generate new knowledge all by itself, using a rule of inference. A classic one is called modus ponens. If the agent already knows the rule, if it's raining, then the ground is wet, and we tell it, hey, it's raining, it automatically figures out a brand new fact. The ground is wet. Nobody had to tell it that part directly. It reasoned its way there all on its own.
But, this simple black and white true or false world, it's got a pretty big weakness. Propositional logic is fantastic for simple facts, but man, does it struggle when you try to express more complex, general ideas about the world. It hits a wall, like really fast, when you need any kind of nuance.
Yeah, this quote just nails the problem. Simple true-false statements, they're just not enough to describe the real world, are they? I mean, how do you say something that's true for an entire category of things? Or how do you state that just some things in a group have a certain quality? Propositional logic just doesn't have the words for it. The vocabulary isn't there.
And here's a perfect example of what that limitation looks like in practice. This system can totally handle a specific fact, like Socrates is a human. Easy. That's a simple true statement, but it has absolutely no way to express the universal rule that all humans are mortal. It just can't make that leap from a specific case to a general, universal truth.
So the big question is, how do we break through that wall? Well, AI researchers basically leveled up. They moved to a much more expressive and powerful language, first-order logic. And let me tell you, first-order logic completely changes the game. It stops looking at the world as just a collection of simple true-false statements. Instead, it starts building a model of the world based on objects, their properties, and the relationships between them. And to make all this happen, it introduces these two super powerful tools called quantifiers.
Okay, tool number one is the universal quantifier. It looks like an upside-down A. And what this does is it lets an AI make these big, sweeping statements about everything in a category. So whenever you see this symbol, you just read it as for all. This is how we can finally write down a rule that applies to absolutely everything.
And the second tool is its partner in crime, the existential quantifier, which looks like a backwards E. This symbol lets the AI say that at least one thing with a certain property exists, even if we don't know exactly which one it is. So you read this one as there exists, or sometimes for some.
And just like that, with these two tools, that statement that was impossible for our old system is now actually pretty simple. All humans are mortal can be written down formally. What it's really saying is, for any object X you can possibly find, if that X is a human, then it logically follows that X is also mortal. We've finally done it. We've captured a universal truth in a way a machine can understand. Now look, this isn't just some abstract exercise for philosophers or mathematicians, okay? This kind of formal, structured reasoning is the absolute foundation for so many critical AI applications, the kind where you absolutely need reliability and, just as important, transparency.
I mean, think about it. From expert systems that help doctors diagnose diseases to robots figuring out their next move, formal logic gives the AI a predictable, reliable way to solve problems. And here's the really crucial part. Unlike so many today's black box AIs, when a logical agent makes a decision, you can trace its reasoning step by step. You can see exactly why it did what it did.
So really, understanding this logical foundation of AI is more important now than ever before. As we start relying more and more on these incredibly complex systems for really high-stakes decisions, it kind of leaves us with a big question, doesn't it? In our hunt for the future of AI, maybe, just maybe, one of its oldest ways of reasoning is exactly what we need to build a more transparent and more trustworthy world.